Hi everyone and welcome to this video lesson. We talk about the first law of thermodynamics and its relation with the principle of energy conservation. First of all, let's take a look at this picture. What happens when you heat up a pot of water? Well, it's easy. If you heat up a pot of water, you transfer a certain amount of heat to the system. Remember that heat is a form of energy, and in this case, in our calculations, we'll indicate the heat with the letter Q. Remember, we have to take into account a sign convention. Q can be either positive or negative. Q is positive when heat is absorbed by the system. Q is negative when it is released by the system. A second thing we have to take into account is that a system can also do some mechanical work. A typical example is a cylinder with some gas in it and with a piston on top of it. The piston can move upward or downwards, doing a certain amount of work. Thermodynamics, the work of the system is indicated with the letter W. There's a sign convention here too. W can be either positive or negative. The work is positive if it's work done by the system. In other words, the piston goes up. The work is negative if we mean work done on the system, and in this case the piston goes down. The third thing we have to consider is the temperature of the gas. If you heat up the gas contained in the cylinder, what about its temperature? It's easy to understand that the temperature of the gas will rise because the kinetic energy of its molecules increases due to the heat absorbed by the system. We need a specific physical quantity to take into account temperature, and the name of this new physical quantity is internal energy. The internal energy of our system is indicated with the letter U. There's a very important thing to say, and that is, for an ideal gas, U is directly proportional to the temperature of the gas. That means that if T varies, U varies consequently. And so we can introduce the concept of variation of internal energy. The variation of internal energy is indicated with the symbol delta U. Finally, we are ready to state the first law of thermodynamics, which is a fundamental physical law and takes into account the heat exchanged by the system, the work of the system, and the variation of internal energy. From a mathematical point of view, the statement of the first law of thermodynamics is quite simple. Q equals delta U plus W. Let's try to understand the meaning of this formula. During a process in which a system exchanges both heat and work with the surroundings, the heat Q supplied to the system turns into a variation delta U of its internal energy and also into work W. Well, now it's your turn. Please pause the video and do the two activities shown right now on the screen. Remember that you can download the activities from our classroom Google Drive area. Once you have completed your activities, upload them to your personal Google Drive area. Activity number 1 is shown here, and activity number 2 is shown right now on the screen. Well, the next step is trying to understand what are the main thermodynamic processes which can be described using the first law of thermodynamics. We have to consider 4 main processes. First one is the isothermal process. This is a process where the temperature of the system is constant during the process. That means that the variation of internal energy is zero, and the final consequence of this is that we can state the first law of thermodynamics in a quite easy way. Q is simply equal to W. The second process is the so-called isobaric process. Isobaric means that the pressure of the system is constant. In this case, the system does some mechanical work. You can determine with the formula W equals P times delta V, where delta V is the variation of the volume of the system. In this case, you have to use the complete formula of the first law of the thermodynamics. Q equals delta U plus W. The third process is the isochoric process, that is a process where the volume remains constant. If the volume remains constant, you have a delta V zero, and that means that the mechanical work of the system is zero. The simplified formula for the first law, in this case, is Q equals delta U. There's one more process we need to consider, the so-called cyclic process. A cyclic process is a process where the initial state of a system coincides with the final state of a system. This is important because in this case delta U is zero, and the first law of thermodynamics is simply in the form Q equals W. Now it's your turn, and please do the two activities shown right now on the screen. Activity number 3 and activity number 4. Now let's talk about the physical meaning of the first law of thermodynamics. We have written down our mathematical formula. We have understood its simple formula, Q equals delta U plus W, but what's the physical meaning of it? We can say that the first law of thermodynamics is a generalization of the principle of energy conservation, which is a very important physical principle. Why is the first law of thermodynamics a generalization of this principle? Simply because it's extended to more complicated systems, that is, systems which can exchange heat and work with their surroundings. So in this case we have to take into account a lot of different things. All of these things can be studied in a single formula by using the first law of thermodynamics. I know it can sound a bit complicated, but it's not. We can state it in plain words, saying simply that if you heat up a system, the energy transferred to the system is transformed partly into mechanical work and partly into a variation of the internal energy of the system. But the important thing is that the overall amount of energy remains the same. In other words, and that's the importance of this law, energy can't be destroyed, energy can't be created, energy can only be transformed from one form to another. Let's take one more look now to our formula, to the formula that you can see here, and let's try to understand it from a physical point of view. If I give some heat to my system, that is some energy, this energy can't be destroyed, and in fact when I heat up my system I will find again the same overall amount of energy, but split in two parts. There's the first part, right here, delta U. That means that parts of the initial energy has been used to increase the temperature of the system, and consequently its internal energy, and part of the initial energy has been used by the system to do some mechanical work. Well, now pause once again the video and do the two final activities shown on the screen right now. Activity number 5 and activity number 6. Well, I think that's all for now, guys. We have studied the first law of thermodynamics, first from a mathematical point of view, and we also tried to understand its physical meaning. Thanks a lot for your attention, and see you in the classroom, guys.